3 and we will see the questions that are related to the space technology. Question is this: match the following. Not exactly match the following, but terms are given, meanings are given, and you have to identify which pairs are correctly matched. So Cepheids, nebula and pulsars. Description is given, which one is correct. So let us see them one by one. Now Cepheids are type of stars which give regular burst of lights, like heartbeat. Our heart beats, right, 60 beats per minute. If you're running, it goes up to 120, 150, 180. So heartbeat has a pulse. Similarly, these stars have a pulse, but in that pulse, they don't pump blood. They release light. Okay, so these stars release light in pulses. Astronomers identify them not only in our galaxy but in other nearby galaxies as well. So if you want to measure the distance to a given galaxy, you can locate, and you should locate, the Cepheid variables in this galaxy, because they release burst of light at regular intervals. So you can detect them in the sky and measure the distance, right? You don't need to go how, you don't need to understand how, but you need to understand the application. Okay, so it is incorrect. The first pair is incorrect. Now we come to the next one. So yeah, before that, Cepheids look like this: less brightness, more brightness. So they will go with light oscillation: less, more, less, more, less, more, and so on, right? So this is how Cepheid star work. Next is nebula. Nebula has a statement, right, which we will see: stars which brighten and dim periodically. We have just seen that these are Cepheids. Yes. So explanation: this is incorrect, of course. Nebula, that is singular is nebula, sorry, nebulae. Singular is nebula, is one giant cloud of dust and gas in space. Now nebulae are vast clouds of gas and dust in space. They are site of star formation. Mostly they are site of star formation. Hence they are also called star nurseries. But they are also found after the explosion of a star. They are thrown out. Okay. For example, in supernova. Right. So nebula, you can see here, over here. You can see it over here. So stars are born from nebula. They will form the different sequences around the formation according to the mass. We don't need to study this right now, right? Just wanted to show you this nebula over here, right? So this is how they look, something like cloud and dust, right? Nothing is specific here. If you see a star, it will be round. If you see a planet, it will be round, right? But here it's just a cloud of dust, gases. Yes. Okay. Third one is pulsars, neutron stars that are formed when massive stars run out of fuel and collapse. So this is the only correct pair. See, pulsars are type of neutron stars. Pulsars rotate very fast. So they are rotating neutron stars. That means the core that is left of the neutron star. See, after the star dies, it turns into a neutron star. And fast rotating neutron star is called a pulsar. So they have pulses of radiation at regular intervals that typically range from millisecond to seconds. They emit beam of radiation, typically in the form of radio waves, but also in other part of electromagnetic spectrum. So here you can imagine a lighthouse. A lighthouse rotates and releases energy, light. It is constantly emitting a light and it's rotating. Yes, but these Cepheids are different. They are static, or they basically release energy at in all the directions. Pulsars release energy in a particular direction. Next point is neutron stars are formed when a massive star run out of fuel, like I've written it over here, and it collapses. The very central region of the star, that is the core, collapses, crushing together every proton and electron into a neutron. This is why a neutron star is formed. So pulsars look like this. They expel radiation from their poles. So let's say the earth is here, right? So whenever this will turn like this and the radiation will come, then we'll be able to see. Similarly, lighthouses, they have a circular motion in the top, right, and the light rotates. Just imagine like a lighthouse, perfectly it will look like that, right? Now there is a term which is called a variable star. You should know that. A variable star, which is also, see, this is also part of connecting the dots. A variable star is quite simply a star that changes its brightness. A star is considered variable if its magnitude, that is the brightness, is altered in any way from our perspective, right, on the earth. And our own sun is a variable star. Examples are Cepheid, pulsars, and our sun. Right? The answer is A. Answer is A. Only the third option is correctly matched.